Alright guys, here we are looking at question 2, and in question 2 we're asked to sketch the graph of 3y plus 2x plus 8, and of course it's a linear equation. And going to be honest with you, in this particular case here, again I would go with the second method, because ultimately the objective is simply to determine where the line would cut each of the axes. So if they're not asking me for gradient or the value of c, and they just want me to do the sketch, then all I need to do is figure out where the line will cut each of the axes. So in this particular case here, I'll just go ahead and use method 2 for speed. So where does the line cut the y-axis? Where does it cut the y-axis? And remember, when it cuts the y-axis, the value of x is 0. So I'm simply going to write the equation and just insert 0 wherever x is, and just solve for y, and that would tell me where the line cuts the y-axis. So this would be 3y equals 8, and then y would simply be equal to 8 divided by 3, and that's the same as 3 into 8 2 times and 2/3, which as a decimal essentially works out to be 2.67 if you want to look at it as a decimal. So right away now I know where the line is going to cut the y-axis. So similarly over here, where does the line of this equation cut the x-axis? And remember, I'm doing this method because they're just asking me to sketch the graph of 3y plus 2x equals 8. If they had asked me to determine the gradient m and the value of c, then I would have to rearrange this. But as far as just sketching concerned, all I need to do is figure out where the line will cut the y-axis, and now figure out where it's going to cut the x-axis. And when it cuts the x-axis, the value of y is 0. So I'll insert 0 for y there, and I'll simply solve for x. So this is going to be 2x equals 8. So x is going to be equal to 8 divided by 2, and x is going to be equal to 4. So now I know where the graph is going to cut the y-axis, and the x-axis can go ahead and do the sketch of this graph. So it's pretty simple whenever you're doing a sketch of a linear equation. Pretty simple. So sketch. Again, whenever we're doing a sketch, always ensure that you have the x and y axis labeled. Very important. So just simply do this. Label x axis and y axis. Very important that you do that. And of course now it cuts the y axis at 2 2/3 is 2.67, and that's positive 2 2/3 on the y axis, and that should be somewhere up here. All right. And of course it cuts the x-axis at 4, and that would be somewhere here. So all I need to do is connect the 2 points. All right, just connect the 2 points just like that. And of course just indicate the values. So it will be 4 here on the x-axis, and 2 2/3 on the y-axis. I like to use fractions because they are precise, but if you want to relay in terms of the decimal, then you can go ahead and put a 2.67, that is fine. So this would be the sketch of that equation here. Pretty simple. Now, if you want to go ahead and use a second method, that is also fine. So let's take a look at the second method here, or the first method rather, so that we're clear. And the first method would involve putting the equation into the general form. So we have 3y plus 2x equals to 8, and what we want to do is to get it in the general form, which is y equals mx plus c. So how do we go about doing that? Now what we have to do is get all the terms other than y on one side of the equation, and then simply make y the subject. So it's not too far-fetched to see how we're going to go about doing that. So it's going to be 3y equals negative, well, let me put the 8 first, minus 2x. So 3y is equal to negative 2x plus 8 if you want to look at it like that. And of course y would simply be equal to minus 2x plus 8 all divided by 3. And we know already from the previous lesson that y is equal to minus 2 over 3 times x plus 8 over 3. So this here would be the general form. So what I did was to simply rewrite this equation into that form. And you can clearly see that it is in the general form here. Now, based on that, we know that the gradient is negative 2/3. We know that. And whenever the gradient is a negative gradient, the line should be in this orientation. And that is exactly what we got there. So, I've found the gradient, and that means I have an idea now of how the line is going to be falling, the orientation of the line. Now, C is also 8 over 3, which is the same as 2 and 2/3. And this is where it cuts the line. So therefore, cuts the y-axis. Therefore, the line cuts the y-axis. And that is what C tells us. The line cuts the y-axis at 2 and 2/3, which is the same thing as 2.67. That is where the line cuts the y-axis. And that is exactly what we got in the method that we used before, right? So seeing that we know where the line cuts the y-axis now, all we need to figure out is where the line cuts the x-axis, and then we're finished, right? We know we already have the graph, but we're just using the alternative method. And this method would make sense if they wanted us to tell them what the gradient was in particular. And in order for us to do that, we'd have to convert the equation from this form into the general form, which we did. So that would be the benefit of going this route if they particularly wanted to know what the gradient was, or wanted us to tell them what the gradient was. If not, if it's just the sketch that they want, then this method will be fine. All they need to find out is where the line cuts the y-axis and where the line cuts the x-axis. And using the knowledge that when the line cuts the y-axis, the value of x is 0. And when the line cuts the x-axis, the value of y is 0, then we're good to go in terms of determining where the line will cut each of these axes. So all we need to figure out now is where the line cuts the x-axis using this method that we've chosen to use. And that is also very simple, because when the line cuts the x-axis, the value of y is going to be 0. So going back to this equation, you could have actually used that one as well, but it's fine. So going back to y equals minus 2 over 3x plus 8 over 3. So determining where the line cuts the x-axis, okay? And remember, when the line cuts the x-axis, the value of y is 0. So we just substitute y for 0 here, and then proceed in solving for the value of x. So we move this negative term over, it becomes positive. And of course, this here, let me just rewrite this step for clarity. And of course, this here, you should know by now, is the same as 2x over 3. Now, when you have an equation and you have a single fraction on one side and a single fraction on the other side, and the denominators are the same, then you can simply equate the numerators. Very simple. So x will be equal to 8 divided by 2, and x will be equal to 4. So therefore, the line cuts the x-axis at positive 4, right? And see now that we know where it cuts the y-axis, which is 2 and 2/3 or 2.67, and where it cuts the x-axis, which is 4, then we could actually go ahead and make a sketch as we did before. So it's really up to you which method you want to use. If they're just asking you to sketch the graph, and especially if the equation is not in the general form, you can go ahead and employ this method if it's just a sketch of the graph that you need. And especially if the equation is not in a general form, then you can use this method to determine where it cuts the y-axis and where it cuts the x-axis. If they want you to tell them what the gradient is, then you would have to go ahead and convert this equation into the general form, which is that, and it'd be easy for you to determine what the gradient is, and what C is will tell us where it cuts the y-axis. Afterwards, then you'd go ahead and equate the equation to 0 to determine where it cuts the x-axis, solve for x, and that is what you should have got. So it's very straightforward, and the method that you choose is really up to you. And again, my recommendation is, if the equation is not in the general form, like this one, and they're just asking you to sketch the graph, employ this method. All right? But if the question has other parts that require you to find the gradient, etc., then you go ahead and employ the method that involves you changing the equation to the general form. So I hope you guys found this video insightful, and I'll see you guys on the next video.